We are on lesson 6, chapter 7. So this is slope and similarity triangles or slope and similar triangles. Essential question is how can you determine congruence and similarity? The objective of this lesson will be twofold. Okay. First objective on this one uh, would require us to understand similar triangles in the coordinate plane. So this is similar triangles and the coordinate plane. And the second objective will require us to understand how similar triangles are related to your slope. Okay, so let's take a look at the real world link. In an experiment using a coiled spring toy, Zoe and Jack determined they needed to raise one side of a 5-foot board, 3 feet for the toy to move. So this is the illustration. One side of the 5 feet board, and you have 3 feet as the height of the board. So in this case, we want to find the slope of the board, and we will be using the Pythagorean theorem. Okay, and if you don't remember the Pythagorean theorem simply states that c squared equals a squared plus b squared. Okay, let's take a look at the next one. So we will use the Pythagorean theorem to find out the far end of the board, to find out how far the end of the board is from the book. So you want to use this. So by using the Pythagorean theorem, we can find the distance between those 2 points. Okay. So draw a triangle formed by point A, which is 0, 2. So 0, 2 is right here. Point B is 0, 4, right here. And point C is 3, 4, right here. So if I'm going to create a triangle, this is how my triangle would look like. Okay, let me redo the other line. So right there and right there. Okay, so what kind of triangle did we draw here? You can notice that this is a right triangle because of that right angle. So this is a right triangle. Draw the triangle form number 2. Draw the triangle formed by D6, 6. So this is 6, 6. 6, 8. And point G, 9, 8. 9, 8. So again, that is our triangle. And this is point D, F, and G. And this is A, B, C. So you have triangle ABC and triangle DEF. So how is triangle DEFG and related to triangle ABC? Okay, if you look at it very closely, they are congruent. Okay, so that means they are congruent, meaning their sides are the same, the angles are also congruent. So the length of the sides are congruent, the length of the angles are also congruent, therefore they are congruent triangles. Okay, now we're going to draw another triangle. Okay, point A is 0, 2, we draw that. 0, 6 is right here. Okay, point D is 6, 6. It's right here. It's point A. Now if we draw that triangle, okay, that's a triangle. that is formed by AKD, because this is point K right here. So that's triangle AKD. It's asking, how is triangle AKD related to triangle ABC? If you learned the last lesson and you understood the last lesson, if two angles of a triangle are congruent, then the two triangles are similar. So in this case, we have two angles that are congruent. This is congruent to each other, okay? And they both are right angles, so therefore they are similar, okay? They are similar triangles, okay? What is true about the hypotenuses of the three triangles, steps 1, 2, and 3? So if you notice, the hypotenuse is the longest side of a triangle. So these are all the hypotenuse. This is where the hypotenuses lie on triangle. Let me really do that. So this is the hypotenuse. What do you notice about all the three hypotenuses? Okay, they all fall on the same line. Okay, so all the hypotenuses of the three triangles fall on the same line. Okay, and all the three triangles are similar to each other. Okay, now how do we find the far end of the board from the books? So if you go back to this problem after answering all these four, you notice too, okay, by using the Pythagorean theorem, we find out that our C here is 5, so that's 5 squared equals 3 squared plus B squared. We don't know what B is, so this is 25 equals 9 plus B squared. Then we subtract 9 to both sides, okay? So subtracting 9 here, subtracting 9 here, end up with 16 equals B squared, okay? And we get the square root of B squared and 16, and we end up with 4. So the length of this one is 4 using the Pythagorean theorem, okay? So what does it have to do with our lesson? Let's find out. So this is our lesson, similar triangles in the coordinate plane. In this figure shown, triangle ABC and triangle BDE are slopes. Okay, remember also when we learned about slopes, that in any single line, the slope will always be the same for that line. Doesn't matter where you find the slope on the line, the slope will still be the same. So if we draw a triangle ABC, which is here, triangle ABC, and triangle BDE right there, okay, they are called slope triangles. Slope triangles are similar to each other. So basically this triangle right here is similar to that triangle right there. That means the corresponding sides of both triangles are proportional. So we know for a fact that angle BAC, which is this one right here, BAC, okay, is congruent to triangle DBE right there. Why do we know that? Because they both have the same arc. So this one has this arc right here, and this one also has the same arc. And since both of them are right triangles, they're congruent to each other as well. In our last lesson, we found out that if two triangles have two angles that are congruent to each other, then the two triangles are similar to each other. So in this case, angle BAC is congruent to triangle DBE, and triangle ACB, okay, which is a right angle, is congruent to triangle BED, which is also a right angle. Therefore, triangle ABC is similar to triangle BDE. Okay, so what this means is simply that the sides of both triangles, the corresponding sides of both triangles, are proportional. Okay, how does this work? Let's take a look at example number 1. Write a proportion comparing the rise to the run of each of similar slope triangles as shown above, and then find the numeric value. So let's say AC over BE is equal to BC over DE. Okay, so going back here, we have AC, this length right here, okay, is proportional to the side BE right here. Okay, and BC right here is proportional to DE right there. If we do our cross products, multiply across from each other, AC times DE will give you that, and BE times BC will give you this. Okay, so AC, to be able to uh, find the value of to find value, numerical value, we use the division property of equality. So that means we divide both sides by DE. Okay, and we divide both sides by BC. So divide both sides by BE, divide both sides by BC. So what's happening now is after we divide them, we end up with AC over BC and BE over DE, because this cancels out and those cancel out. Okay, we know that AC is 6 units. Okay, and BC is 3 units. AC is 6 units. One, two, three, four, five, 6. That's where you get 6. Okay, and BC is 3 units. 1, 2, 3. That's where you got 3. We also know that BE is 4 units. BE, 1, 2, 3, 4. And DE is 2 units. 1, 2. So if we do our similar corresponding sides proportion, we now have 6 over 3, which is AC over BC, is equal to 4 over 2. And if you notice, those two form a proportion. How do we know that? Because if you do the cross product, 6 times 2 is 12, and 4 times 3 is 12, and 12 is equal to 12. Okay? So that's how we are able to prove that these two triangles are similar to each other. Okay? Okay, let's do got it number 1, or letter A. Graph triangle MNO with vertices 3, 1 for point M, point N10, and point O30, and triangle PQR with vertices point P for 5, 2, point Q negative 1, and point R at 5, -1. And write the proportion comparing the rise to the run of each of the similar slope triangles and find the numeric value. Okay, first, let's graph them. So the vertices of triangle MNO are 3, 1. So 1, 1, 2, 3, 1. This is point M. Okay. Point N is 1, 0. It's point N. And point O is 3, 0. Okay. So this is triangle MNO. Okay. Let's do triangle PQR with vertices point P is 5, 2, 4, 5, 2. So make that red. Okay. Q negative 1, negative 1 right here. And point R 5, negative 1. So this is point R. This is point P. This is point Q. And if connect them all together, this is how the triangle looks like. And if you notice, there are slope triangles because both their hypotenuses lie on the same line. Okay? So it says here, write a proportion comparing the rise to the run for each of the similar slope triangles and find the numeric value. So when you talk about rise over run, and we talk about triangle M and O, if you look at M and O, the rise, okay, is 1 going up, and the run is 2. So rise going up, one unit going up, 2 units to the run. So in triangle M and O, rise over run is equal to 1/2. Okay. In triangle PQR, okay, our rise for triangle PQR is 1, 2, 3, 4. So that's 4 units. Our run is 1, 2, 3, 4, 5, 6. So 6 units. Okay. So if I start here, I'll count 6 units to the right. 1, 2, 3, 4, 5, 6. And 4 units up. That's the reason why my rise over run for triangle PQR is 4/6. Okay. So since that's the case, triangle MNO is similar to triangle PQR because they are similar triangles. So MNO is equal to 1/2 is equal to 4/6. Sorry, that's not 4, that's only 3/6. 3, 1, 2, 3. I counted wrong, so this is 3. And if you notice, those two ratios are proportional. Again, how do we check it? If we do the cross products, that is 6, that is 6, and that is the numeric value. Okay? So let's look at similar triangles in slope. The ratio of the rise to the run of two slope triangles formed by a line is equal to the slope of the line. So what does that mean? If you look at the larger triangle, the rise over run of the larger triangle is 6/3. So the rise is 6, 1, 2, 3, 4, 5, 6. That is 6. The run is -3 because you go to the left, 1, 2, 3, -3. Okay? So if you do rise over run, it's 6/-3 or -2. Okay? The rise over 1 for the smaller triangle, okay, start from this point. Since you're going up, it's +2. And since also you're going to the left, it's -1. So the rise is 2, okay? Run is -1, or 2/-1 is -2. So the slope for this particular line using similar triangles is -2. The ratios of the rise to the run of the two similar slope triangles in example 1 are the same as the slope of the line. Since the ratios are equal, the slope m of a line is the same between any two distinct points on a non-vertical line in the coordinate plane. So basically what it's saying is the ratio of this triangle right here compared to this ratio of this triangle right there is the same. So that means if you find the ratio of rise over run of this small triangle and find the ratio of rise over run of this triangle, they should be equal to each other. Okay? Now let's go through this. So we want to find the slope, okay? Okay, of that line. So the pitch of a roof refers to the slope or of the roof line. Choose 2 points on the roof and find the pitch of the roof shown. Then verify that the pitch is the same by choosing a different set of points. So again, the formula for slope, you remember this, is still y2 minus y1 over x2 minus x1. We use the points, point S, which is this one, and point R, which is that one. Okay, so you have x1, y1 is 8, 6, and x2, y2 is equal to 12, 8. Substituting into this formula, you have 8 minus 6 over 12 minus 8. Okay, end up with 2/4 or 1/2. The pitch of the roof is 1 over 2 or 1/2. Verify that the pitch is the same using 2 other points. So let's use 2 other points. Okay, in this case now, instead of using SR, we use U and T. So this is point U, and that's point T right there. So the point x1, y1 is 2, 3. x2, y2 is 0, 2. Substitute the values right here. Again, you end up with 1/2. So you notice that the slope is the same for both triangles. Okay? And we just answered the question because it's asking verify that the pitch is the same by choosing 2 different set of points, and we chose 2 different set of points, S and R and U and T. We ended up with the same slope. Okay? So, any questions on this one? Let me know when we do our video conferencing. Thank you.